The next thing we're going to do, based on that Desmos activity that hopefully you took a look at, is we're going to try to figure out some specific values of constants that would make a piecewise function continuous. Two examples of this. We're going to first take a look at this function f of x equals 2x cubed minus 4 when x is greater than or equal to 2, ax plus 2 when x is less than 2. I want to figure out what value of a would make the function continuous. Well, first of all, there's only one place I could be discontinuous, where I jump from one piece to the other, at x equals 2. I need to make sure that function is continuous at x equals 2. And since it's continuous, that must mean that the limit as x approaches 2 from the left of my function must equal f of 2, must equal the limit as x approaches 2 from the right of the function. We're going to be continuous, so all three of these things must be equal. Notice my notation's a little different than what I did in the previous video where we were trying to figure out if something was continuous. If we're trying to figure out if it's continuous, I need to really do those three things separately. But here, because we know it's continuous, I will start with this three-part equation, saying this has to equal that, has to equal that. Okay, well, now let me go find these. The limit as x approaches 2 from the left of the function means plugging 2 into that bottom piece. I'm going to get a times 2 plus 2. F of 2 and the limit as x approaches 2 from the right of the function both involve me plugging into the top piece. I'm just going to kind of deal with these in the same way. And I'm going to say this is 2 times 2 cubed minus 4. Well, all you have left to do now is go solve the equation. So do it. Go solve. Tell me what a is. And let's take a look at Desmos just to make sure that worked. Perfect. So we saw from that graph, when a equals 5, yep, that function's going to be continuous. Let's try one more, a little harder. Find a and b. So f of x is continuous everywhere. So I'm going to let f of x equal the function negative x squared plus 2 when x is less than or equal to 1, ax plus b when x is between 1 and 3, and x cubed when x is greater than or equal to 3. The two places I need to make sure my function's continuous, because it'll have to be continuous everywhere else, 1 and 3. At x equals 1. I would like you to set up your three-part limit equation and then create an equation using a's and b's out of that and submit that through Edpuzzle. So before we do anything, we really do need to show this line with the limits. I will be looking for that on quizzes and tests, as will the AP exam. Really everything in here I'm being picky about. I'm being picky about because of the AP exam. I need these three things to be equal. As I approach 1 from the left and right at 1, I'm on my top piece, so negative 1 squared plus 2 equals a times 1 plus b. This isn't negative 1 squared, it's negative 1 squared. We're plugging in a 1, we're doing the square first. Hopefully you realize that. This is negative 1 plus 2, that's 1 equals a plus b. Hopefully that is what you submitted in Edpuzzle. Go do the same at x equals 3 and submit that equation in Edpuzzle. We've got the limit as x approaches 3 from the left of f of x, which has to equal f of 3, which has to equal the limit as x approaches 3 from the right of f of x. And here to the left, that's going to be a times 3 plus b. When you're to the right and at x equals 3, you're going to get 3 cubed. So hopefully you submitted 3a plus b equals 27. Well, what do you know? We've got a system of equations. Go solve that system, tell me what a is, and tell me what b is. Hopefully you said a is 13. And then looks like b is going to end up being negative 12. And that's how these work. This is a pretty standard type of question that shows up on the AP exam, so definitely make sure you know what's going on with these.